Computers can only understand and process data in zeros and ones. While we might have emojis, we might have letters and numbers outside of zeros and ones, the way that computers actually process everything is only through zeros and ones. Let's learn how that actually works. In this video, we're going to be defining what binary is. We're going to be talking about bits versus bytes. We'll be talking about decimal to binary. We'll be talking about hex as well. And finally, we're going to be talking about ASCII versus Unicode. Let's dive into defining binary first. Binary is simply a numbering system used by computers that represent our data. Again, computers can only use two values, the number 0 and the number 1. Some important binary details here are binary consists of bits where each bit is either 0 or 1. It's used to represent all types of data and to do everything in the background. So for example, our text, our numbers, our images, our audio, our instructions, our software, it's all zeros and ones. Binary allows our computers and our other devices, such as smartphones and tablets, to process, store, and transmit information using electronical signals. So zeros and ones are essentially just electric signals. Now, here's the thing. Our computers are doing different types of calculations, and zeros and ones do have a meaning. 0 represents something being off or false, or no electricity on the computer component being present, and 1 represents something being true, on, or that there is electricity present. So in the most simple terms, 0 means no electricity is present, 1 means that there is electricity present. By far, that's one of the most simple ways to understand it, and you do need to know that for the Tech Plus exam. So to summarize, binary is our simple way that represents data that computers process only being zeros and ones. One important thing that I wanted to talk about here, focus on understanding the concepts that we're talking about in this video. Just understand that the concepts, what they are, the conversion between different types of systems is possible, and why we actually convert things. Don't worry too much about conversions. We're going to be talking about quite a few different concepts in this video, but I don't want you to get carried away. Don't worry about being able to convert different types of conversions and being able to do these exact conversions. That's not as important as you understanding what these concepts actually mean. So let's continue on here. Let's talk about bits versus bytes. Bits are our binary digits. They're the smallest unit of data possible. They represent zeros and ones. Again, our devices, computers, laptops, tablets, whatever it is, smartphones, they think and process data in zeros and ones. Bytes are a group of 8 bits. So 1 byte is equal to 8 bits. They usually represent something like a character or a number. In terms of primary use, bits are used for data transmission, and bytes are used more for measuring data storage and memory size. An important note here, lowercase b equals bits, uppercase b equals bytes. 8 bits equals 1 byte. Here we have a graphic on screen showing that 1 byte is equal to 8 bits. So when we enter other numbers, such as the number 22, the computer processes that through zeros and ones. This is what these numbers would look like in binary format or using solely zeros and ones. For example, 2 would be 0010, 8 would be 01000, 16, 10,000 or 10000, 22 would be 10110. Again, this is how the computer interprets our data. So no matter what we're working with, binary is always there. No matter if you're using numbers, if you're using emojis, if you're using letters, if you're using anything, that's how our computer processes data, is through binary and through zeros and ones. And this is just an example of what some numbers might look like or do look like in binary. Next is decimal to binary conversions and the concept. Don't worry too much about understanding how to do this. Focus more on understanding this. So in simple terms, humans use decimal format many times. Computers use binary. Conversion is just the translation between binary to decimal or decimal to binary. Don't worry too much about doing the conversion, just understand what this means from a concept level. Next up is hex, and if you've ever used anything involving color, you've likely encountered hex. For example, if you used a 6-digit code in order to grab a certain color in Canva or in Photoshop or in another type of graphic editing software, you've used hex. So hex is a simple way to write binary so that we don't have to read long strings of ones and zeros. It uses the digits 0 to 9 and the letters A to F to represent values. Hex is extremely commonly used for color codes. Next is notational systems, including binary, decimal, and hex. This is what each of these would look like. So binary might be 1010, which would equal decimal format of 10, and in hex format, that would be A. Binary 110011 would be 51 in our number and 33 in hex. binary 1110000 would equal 240 in the way we commonly understand numbers, and in hex format, that would be F0. These are just examples. Again, don't memorize these specific types of conversions, but just understand we can convert binary to decimal to hex and back and forth. Here we have ASCII versus Unicode. So this uses 7 or 8 bits to represent simple and basic English letters, numbers, and symbols. Unicode, on the other hand, uses a much longer character set to represent everything from emojis to symbols to different types of languages. Essentially, Unicode is everything that ASCII has plus emojis. For example, the letter A can be represented using ASCII, but an emoji like this emoji here on screen or any emoji we use requires Unicode. Here's a comparison. On the left here, we have ASCII. You can see these are limited set of characters. For example, A, 65, B, 66. Next here on the right is Unicode. For example, we have A, we have this combination, and we have emojis as well. So that's a little bit of a look at how computers actually process data and what binary is all about. Remember, don't focus on understanding how to do all of the fancy conversions. Focus mainly on understanding each of these topics and what binary is as a whole for your exam.